Okay, that's good. See here, let us take an extent of an yesterday discussion itself. Here, if you observe, this is a particular model. If you observe, let us take, this is a particular model. Now, we are training the model with a data set. Okay, we are training the model with a data set. Whenever we are training the data set to a model, observe careful, the data set is going to be splitted. Okay, the data set is going to be splitted into an multiple parts. Means how x variable is we considered as an independent variable. X variable as an independent variable. This x variable also called as an input data. Okay, and this particular y variable is an dependent variable where we call it as an output data. Okay, output data, output data, and xy. Totally, these two we call it as a data set. Okay, data set. Now consider here consider here this completely fully we call it as a data set. Okay, this particular data set, what we are doing here means, first we train the model. First what we do, train the model. Okay, with how much percentage of an data? 70 percentage of data we will take. This is an a variance. You can, if you want, you can take 80%, if you want 60%, but defaultly they will consider 70% of data is an a perfect data from the whole data. Okay, 70% of data we are taking to train the model. Okay, and test the model. Test the model. How much percent we are taking data? 30% of data. Okay, 30% of data we are taking to test the model. Now observe careful here. To train the data, how the data is going to be splitted? This two is an in whole data set. No, here observe careful. X underscore train data. Okay, y underscore train data. X train and Y train. Okay, and then now if we consider here, X underscore test data, Y underscore test data. Okay, we are splitting the data into 4 particular variables. Okay, X is an input data, or we can call independent variable. Y is an dependent variable, or we can call output data. To train the particular model, the data is going to be splitted to this particular 4 patterns. Means input data, input to train, output to train, input to test, output test, input test, output test. Let us consider I have an same 1000 records. Okay, in this particular 1000 records, I am taking an 700 records, to train the model, and 300 records to test the model, Now observe careful. Once again, let us take into the consideration these particular data we are sending to train the model. Now observe careful. Whenever we are training the model will start gaining the knowledge. This is called an model fit. Okay, here we need to understand the most important thing. We need to think about the terminologies. The terminologies are the very important. Okay, terminologies are very, very important when we are learning the subject. Based on your terminology only, we can identify the percentage of the subject what we have gained. Okay, now observe careful here. The model gains knowledge while training. While training, this particular knowledge is called, okay, observe here, this particular knowledge is called model underscore fit. Model fit, we call it as model fit. Okay, whatever the data means, by using an data we are training the model. This particular model will start gaining the knowledge. That particular knowledge is called as a model fit. Okay, model fit. Now in generally what happen in our regular traditional way of an live about the machine learning, in generally in all other traditional way of an processing, what we do here means we will deploy the algorithm to an production level environment. Algorithm to the production level. But in our machine learning or data science disciplinaries, what we are going to do here means we want to deploy the model to an production environment. Let us consider this is our production environment. If you observe here, let me consider this is our production environment. Okay, some cloud production environment. Now in what they will do in all other traditional way, they will deploy the algorithm directly. They will deploy the, if this is an algorithm, they will deploy the algorithm directly to a production level. But in our regular environment, in the machine learning or data science disciplinaries, we deploy the knowledge. We never deploy the model. Okay, we deploy the whatever the knowledge it has been gained, that particular knowledge to a production level. This is one particular part what we need to discuss, okay, here. And now once the model started training and training has been completed, once the model training is completed, next if you observe here very clear cutly, we are using an a 30% of data, we are using an a 30% of a tested data to test the model, to test the model. Try to understand one particular thing we need to understand here. What is that particular thing means? Whenever we are training here, we are taking an input data and output data to train the model. Okay. Now by using an this particular model we are training here. Okay. Once we train this one, whenever we are testing here, we will take an input data of a y test. Observe careful, y test. Okay. We want to take an output data of an, sorry, x test we are taking here, and we won't take the y test. We predict the values with an x test whether they are working perfectly or not. Whether the output we are getting, whatever the output we are getting, it is perfectly or not. Okay, means here we are training the model and we are testing the model. Once in the testing, we will identify the accuracy test. We identify the accuracy test. What is an accuracy test? Whatever we have worked, accuracy percentage, whether it is getting an a 90% or 70% or 60%, whatever the thing. This is an in general regular environment of an machine learning and a deep learning process. Training the models and acquiring the knowledge is, this is an a most important thing. All the means all the models in the deep learning or everywhere we are going to see this kind of an a process only. These are the basic steps we need to know and we need to understand. Is everyone okay up to here? Is everyone okay? Yeah. Now that's good. Observe careful here. Just a minute here. See, when you are working, be careful about an I don't know, someone gone with an a video. Who gone with an a video? check it out video, yeah. Don't go with a video section, okay? Okay, that's fine. Let's come to here, our regular section. This is a model once again, okay? There are two particular data set. Let us consider this is a particular data set, and this is an other data set. Sorry. Here I have an 1,000 records, and here I have an 10 crore records. Okay. Now, from which data set this? Let us consider this is an A and this is an B. Now, my model need to be perfect. Means I need to gain more knowledge, which is the best data set to train my model. Which is the best data set to train my model, A or B? That's good. 10 crore records. Okay, 10 crore records I have in the B. Okay, that's good. Why we are considering B? Nikit, it's an a B, okay? Because observe careful, here we have a huge number of records, means how many books we read, that much amount of knowledge we are going to gain in a simple way, okay? Here we have a 10 crore records to train our model to get a huge knowledge, okay? Now, whenever we train with the lowest amount of records, means with the low amount of records to particular model, then we are going to be called these particular training pattern model underscore underfit, model underfit. We are going to call this one whatever the knowledge gained by low amount of data, knowledge gained by low amount of data, okay, of data is considered as a model underfit. The simple way, okay, whenever we are training the model with the low amount of data, then we are going to be considered it as a model underfit. This is a very simple way, very easily we can identify this particular model underfit. By using this model underfit, we can't deploy this knowledge to a production level because we won't get an accuracy. We means maybe few people before one day of exam, if we read start subjecting, luckily we need to pass or we need to get distinction. Pass, everyone will become pass, but distinction, to get a distinction we need to struggle from the day one to get a distinction or a 90% in the exams. If one day batting, if he get a 90% means very lucky he is the person, okay? Leave about that one here. If you observe with a low amount of data, when we train the model, it is called as a model underfit, where this particular model underfit is we won't utilize this model underfit for our production level because the knowledge whatever it has been gained, it won't be up to the mark. Okay, this is the thing. Now next here, if you observe here, let us consider the second example of data. Let me consider I have an 130 crores of an Indian census population other data. Let us consider. Okay. Now in this particular other data, what happened here? I'm training, means I am training the model by using an 130 crore records, means 130 crore records of a 70%, means roughly I am taking 75 crores of records I am taking to train my particular, roughly I am saying, not exactly, 70%, 70% maybe 80 crore records or 85, I don't want to calculate. I'm taking this particular amount of data to train the particular model. Now, observe careful, there is a one peculiar thing we need to identify in this particular pattern. Uh, Here we are saying to, we are training the model to gain the knowledge. Means this particular knowledge is nothing but, identifying the new patterns. Identifying the new patterns. Okay, new patterns means new scenarios, new pattern of generating a revenue. We can call it is in a different business aspects. We can call them in a different business aspects. As per right now, we are identifying patterns. Let simply we call it as to identify new patterns. Whenever we are training, suppose example objective 10,000 for every first 10k records of male are there, second 10k records of female are there. There are 75 crore records of data. In that 75 crores of records of data, how it is there? 10,000 records of male, next 10,000 records of female, next 10,000 records of again male, okay, and 10,000 records of female. Observe careful, we need to identify one peculiar thing here. What is that peculiar thing means? For every 10,000 records, the gender has been changing. Is everyone okay with my voice? Is everyone okay? Okay. Triveni, please check it out, okay? Because is everyone okay with my volume and the voice? Is that right now okay? Is now okay? It's fine. Fine. See, observe here. Whenever we here we need to identify one particular thing. What is that one means? For every 10k records, there is a gender change. Okay, whenever we are training the model in this particular data set, here we are training with for every 10k records there is a change of a gender. Now whenever the gender this is considered as an one particular pattern. Now what happened here, the model has been started gaining the knowledge. Okay, the model has been started gaining the knowledge. Now this particular knowledge has some pattern identification. Okay, what I am doing here, these particular pattern I am deploying in some production level. Okay, I am deploying in some production level. Actually this is not a scenario. This is not a scenario, means it is a wrong pattern. In virginal data, for every 10,000 records the gender is changing. This particular phenomena, it has been identified by the model. By the model. Now this particular knowledge, when we deploy into a production environment, what happened here? Observe here what happened the scenario. First 10k records, it is a male. Okay, second 10,001 record also male, but it is showing a female. Okay, let us consider 20,000 records female, it is there. Let us consider. Okay, 20,001 record also female, but it is showing as a male. Means what happened here? The pattern, whatever it is there, whatever the model has been gained the knowledge, this is an extra knowledge it has been gained. extra knowledge it has been gained, where this particular extra knowledge is making an issue. This is called an model overfit. Overfit means here, this is the, in this particular example, this is the one of the particular example, means in this particular data set, this is the one of the example. If we go on behind, if we go on behind, whenever you handling with any different data sets, different data sets at the time, let us consider the second example of the model overfit. Let me take an weather data, weather data. Okay, in this weather data, let us take past 25 years of data I have, past 25 years of data I have. Okay, in this particular past 25 years of data, in this some particular days, it is completely, it is raining every year. Then it will show in the 26th year also it will rain. 26th year also it will rain. Here it should not identify blindly in this particular pattern. It should not identify blindly in this particular pattern. This is considered as a model overfit. If you have a huge amount of data also, means it is not a drawback. We need to overcome this particular drawback. How to overcome or this particular thing? Observe careful the shuffling process. Shuffle the data. Shuffle the data before training the model. Before training the model. Okay, shuffle multiple times, then the data is going to be shuffled. Whenever you shuffle the data, in generally what we do means random shuffle, we do random state, we call it as a random state equal to 101 or 50 or 100, 500 times. It will shuffle the 101 times all the data. Whenever it will shuffle the data, there are chances of getting less model overfit. This model overfit as a very dangerous, because we here, if you observe, model underfit we can identify very easily, because with the low amount of data, easily we can say it is a model or underfit. But whenever you have a huge amount of data, directly we should not go for the training the model. Directly we should not go to train the model. Means we have plenty of other steps we need to consider, but in that particular consideration, shuffling the data is also a major step we need to take into the consideration. This is called model overfit. To overcome the model overfit, we need to shuffle the data before training the model. Okay, before training the model. Did you get it, everyone, up to here? Model underfit, model fit, model overfit. Please let me know. Now let me show you one small example I want to show you. I want to show you the difference between the machine learning and the deep learning, how actually it looks like. See here, deep learning is a subset of machine learning and used to extract useful patterns from the data. Whenever we come to here in the machine learning, input data, feature extractions has been done by a human. Okay, classification, and we are identifying the output. Okay, now in the deep learning, we are taking an input data, okay, and a feature extraction and a classification by using any deep learning neural networks, okay, and getting an output. Okay, here this particular human interface will get off, where we call it as an ANN and RNN, where for this particular ANN, RNN also we are going to add OpenAI, where to act as like a smart act smartly, where we call AI integration. Okay, this is the particular difference between the ML versus DL. Okay, and if we go in depth of this particular, where the AI is going to come into the picture, in the AI itself, we are going to be called, what is an AI? A technique which enable machines to mimic human behavior. That's a true thing. What is mean by an artificial intelligence? Where we are making some product to act like an a human. We are adding the knowledge to that particular product to act like an a human, or to act like an a knowledged product. Okay, and the machine learning subset of AI techniques which use statistical methods to enable machines to improve with the experience. Okay, and the deep learning subset of the machine learning which makes the computation of multi-layer neural network. Here neural network based working environments comes into picture. Okay, completely multi-layer neural network feasible. Okay, this is a particular definitions you need to, the definition should be very perfect. Now you need to take consider these particular definitions. Okay, the first question, what is the meaning? There is, we don't have any proper definition. We need to give a perfect meaning in a single statement. Perfect. What is the AI? The perfect meaning, a technique which enable machines to mimic human behavior. Simple, simple. And then if they ask, we can elaborate. We are transferring the knowledge, or we are training the products, or we are training the models to act like an a human intelligence. Simple way. Okay, we need to elaborate. See, plenty of openings in December. You're going to get it. Mostly December, January, unlimited of openings you're getting. Yesterday I discussed with one of the MNC lead, means production level manager. We got on one particular meeting with the TCS production level manager. They, from March onwards, they stopped building any new products, designing of new products. They totally started migrating their products to an intelligent products. Means they are deploying to an deep learning environments completely. Means that they want to redesign the products into completely deep learning. Once it's happened, means once it will take a migration process, almost it will take 2 to 3 years, but in the meantime, if it completes, the jobs completely will be closed. I'm not saying all the stuff, but almost more than 50% jobs will be closed. And so all other jobs are going to be closed very soon. Okay, be conscious and don't leave the subject here. Don't leave the subject. Now next here, next thing we are going to take into the consideration here. See here, we are calling an libraries. Okay, libraries. What is a library? Collection of in generally library is a collection of books. Now in our particular environment, the libraries or something where collection of an a simple logics, collection related to the logics, algorithms, all we are going to keep in a particular model. Now observe careful here, we are going to utilize scikit-learn. Okay, scikit-learn is one of the library where all the models, all machine learning, all ML models exist. Okay, all the ML model exist in the scikit-learn. What is mean by a scikit-learn? Okay, scientific kit learning. Okay, scientific scientific kit learning. Okay, learning. Okay, now we are going to be called, there is one more thing, scikit image. We call it as a scientific kit scientific kit image, where this is a particular library where it will hold all the models and related stuff to the machine learning models. All the methods and models, everything packages are going to be deployed in this particular library. Always we are going to call the scikit-learn to work it out. Okay, now this is the thing we need to know. And just I want to show you the steps how we are going to be worked with this particular machine learning approach. Okay, the machine learning approach, how it is going to be solved it here. Okay, first thing what we need to do here, the first step we need to consider here, understand the problem or data set, extract the features. Okay, 0 1, identify the problem type, okay, choose the right model. This is one of the important thing. And train and test the model, split the data, then find the accuracy. These are the 5 most important steps. Not only the machine learning, deep learning, and NLP. If you go on, these are the particular steps, mandatory steps. Later on we are going to do some more thing, but these are the particular steps. 100% we need to work it out. Okay, now if you observe, let me show you how the scikit-learn is also going to be helpful for here. Okay, scikit-learn is a powerful modern machine learning Python library for full and semi-automated data analysis and information extraction. Okay, in the scikit-learn, we are going to be organized. There are free open data sets. Okay, if you observe free open data sets, we have a rich set of libraries for learning and predicting. Okay, and open source and the savings we can do, and the support for all the models. Okay, and effective tools to identify and organized supervised and unsupervised models. And if we go behind, if you observe scikit-learn problem solution, the steps what we have seen previously: model selection, estimator object, model training, predictions, model tuning. Model tuning we are going to see later on in the deep learning. Okay, and accuracy test. Okay, and if you observe, to work with a machine learning model, we need to follow few steps. What are the particular few steps we need to follow? Means data data set is a mandatory, which we call data acquisition. Okay, data acquisition. And the next, if you observe, data data exploration or data exploring. Okay, we need to know what are the variables in a data set. Next, variables means here columns we can say. Okay, columns or variables. Explore the data set, what we are identifying, variables in the data set, and specify input and output. Means what we can call it, this one, specify x variable and y variable. Specify x variable and y variable. And if required, we need to go data manipulation. Okay, manipulation, or else we can call data cleaning, or we can call data pre-processing. Okay, and the next, once the data set is ready, split the data into x and y variable. Once we split the data, then what we need to do, split data to train and test model, test sets, train and test sets. Now select particular model and train the model. Okay, this is an next step. Next, once you select the model, train the model. Test the accuracy. Okay, accuracy. Here when we are testing, we have a predict and test. Okay, or give me a sec. predict predict and test the accuracy. These are the steps we are going to follow when we are going to work with machine learning patterns. Okay, now next thing we are going to see, the direct working environment is the most important thing. We need to start working. Before start with work, let us see what is mean by data mining. Okay, data mining. Data mining is something extracting the data from the raw data. Let us consider you have any raw data. What is mean by a raw data? Where without processing, you're going to get into a huge clusters. Directly the source may be customer source, or a web source may be the websites or mobile applications or some machines generated, whatever it may be. Source directly the data is coming and settled down in the particular location where we consider it is in a raw data. From raw data, we are extracting into a departments like this in this particular pattern. Okay, data mining. Okay, data mining by using different tools. By using different kinds of tools, we have plenty of tools in the market. If you observe, even by using a SQL language also, we can do the data mining, or pig language, or a high language, or SQL or Teradata language, PLSQL, anything. We have plenty of tools. Even reporting tools, Tableau also we can utilize it to work with this particular to work with raw data extraction. Okay, let me show you something data mining image, how it looks like actually. Give me a second. This is a particular image of data mining. If you see here, this is raw data of something customer relation CRM. Okay, from the CRM, e-commerce, marketing, finance, services sector, fraud detection, e-commerce, marketing, banking, health sector. We can utilize customer segmentation, marketing, economics, research analysis, healthcare department. Okay, e-commerce, market basket analysis. This is a very important. Okay, everywhere recommendation engine also they are calling. Okay, forecasting, prediction analysis, business analysis, marketing, risk management. These all are the particular stuffs where data mining from the main data set we are extracting the data. Okay, extracting the data. Okay, and just give me a minute. Just give me a minute. So, okay, right. Now this is some data mining process we are going to see, and let us start working with any models. Okay. Now observe here in the machine learning. In the machine learning models are splitted into three different categories or three different types. Okay, what is an a first type? We have called it supervised supervised learning. Okay, and the next one unsupervised learning. Okay, unsupervised learning, and the next one reinforcement learning. These are the three particular categories under the machine learning. Now try to understand here. We need to go. Yeah, Markandeya, we have seen in the deep learning though, model tuning in machine learning, we can't do it. Okay, we can go in depth, but in the deep learning, we can do it. No, that's what we call EPOS. We have seen no in the EPOS, EPOCHS. EPOS equal to 5 means the whole data. One EPO equal to the whole data set is going to be run once. 5 EPOs means 5 times it is going to be run. Okay, for each, the difference between each EPO, we are increasing the accuracy in the each EPO. Yeah, square root distance. Okay, each EPO is considered as a tuning part itself. Yeah, we have an multiple measures. Means actually in the deep learning, what happened here means we take the sequential, no, model dot sequential to declare all the stuff. Okay, this neural network stuff. Whenever we are declaring, we are going to declare some methods, sequential methods. That sequential methods we have a multiple. In generally ReLU we are going to be taken into the consideration. Okay, rectified. In the ML we will see cost function, different cost functions. F of x is simple, we call it as an f of x function. Okay. Okay, just remind me when we cross the logistic function, how we are going to declare the cost. Okay, maximum we declare in the deep learning itself the cost function also. In the deep learning we see very rare. Okay, come back to here, sorry. Okay, here supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning also we have two particular categories. See here, based on the data, whatever the model we are selecting, observe careful, model selection selection will depends upon scenario is a secondary and data set. Observe careful, based on the data set x and y variable. Based on the x and y variable and the scenario, we are going to select the model. Okay, now let us see in the supervised learning, we have two different categories. We call it as two patterns, regression regression models and classification models. Okay, classification, regression and classification models. Okay, now whenever we come to a regression models, what are the regression models? If you observe carefully, data which is continuous data, let me call continuous data, or we can call whenever you handling with any numeric data. Now especially whenever we are discussing continuous data or numeric data, we focus on the output data. Observe careful one thing, we focus on the output data. If the output data is continuous, or a numeric data, because whenever again I call numeric data, in the classification output also we will get a numeric data of 0 and 1, also numeric data. But whenever you have an 0 and 1, this is called as a classification. Based on your input data, the output is classified either 0, or based on your input data, the classified it may be 1. Depends upon your input data, your data is classified to 0 or 1. Don't think this is an numeric data, but it will falls under the classification, where the output data is a continuous data in the numeric format output. Then we select for the regression models. Whenever the data is a classified data, classified data, where you are identifying the classified data, output data whenever it is an classified, whenever the output data is classified, something like 0 1, not only the 0 1, true or false, or something like 6 faces, or if you go behind heads or tails, like this, the classification based on the departments also we can call it. In a company, the data is classified into a department based, means all the name, surname, age, mobile number, everything, and he belongs to a particular electrical department, and the name, surname, age, everything is there, and he belongs to a computers department, like this. This is called as a classification data. Means here you need to consider two main objects before selecting the model. First one, the data set output, the data set and its output. Second one, it's a scenario based, we discuss when we are selecting with models, when we are selecting with the models. Now in the regression pattern, what are the models we are going to see here? The basic thing, linear regression, linear regression model. Okay, second one, linear and multilinear, or comes under the same regression model. Next one, logistic regression model. Okay, and if we come to here, okay, let us see this one, and we come to a classification models. Okay, the basics of this one, and we go with a classification models. Tomorrow we start with this particular regression model example, and we go further. Okay, hope everyone is okay up to here, and I am going to send you some basic questions today. Mathematical expressions, I'm expecting you people need to complete that one. Thank you. Closing the section. Thank you.